Okay, so we're still talking about the distance formula. But we're going to take a shortcut, the Pythagorean theorem shortcut. Because if you can recall from yesterday's lesson, the distance formula is just Pythagorean theorem, but on a coordinate plane. Seems a little bit more crazier. It seems it's like it's on steroids. Just for fun, up here, let's write the distance formula. D is for distance. Then you have the giant square root. And then we just have some generic coordinates. So it's x sub 2 minus x sub 1 squared, y sub 2 minus y sub 1 squared. That's the distance formula, something you gotta know, something we'll use throughout the school year. It's always good to work hard, always. Sometimes it's a little bit gooder to work smarter, all right? What do I mean by that? Well, we have a shortcut. We can make problems really easy. And we have our good friend Pythagoras. Here's a little funny thing about him. Not walking the legs and making the hypotenuse. Haha, that's funny. Anyways, here is a right triangle. All right. Now this is going to shock you, but a right triangle has 3 sides. Gasp. Shocking. All right. Now, this side right here is the hypotenuse. How did I know that? Well, I'm really smart, but there's some techniques you guys can use so you guys can always correctly identify the hypotenuse, all right? It's the longest leg, or longest side, I should say. It's the longest side. Now, you might not be able to tell which one's the longest side always just by looking at it. It might seem really close at times. It's also opposite the right angle, all right? It does not touch the right angle. All right, so that's some hypotenuse facts. Every right triangle that has existed in the past, present, or that will be drawn in the future, the hypotenuse is always the longest side. If you can draw me a right triangle where the hypotenuse is not the longest side, I'll give you $1 million. All right, now this is gonna shock you too. Triangle has 2 legs, so this is leg 1. We'll call this leg 2. Really, this order doesn't matter. All right, legs, by process of elimination, they're the shorter 2 sides, and they form the right angle. All right, that's how you identify those. And then typically some fun facts, I guess we can, this is important. We usually call C the hypotenuse and the legs are A and B. Now, C is very important. That has to be the hypotenuse. We'll call this one B, this one A, and this one C. C has to be the hypotenuse, but A and B, those are interchangeable. They're just legs, so those really don't matter. All right, so those are parts of a right triangle. This is stuff we're going to be referring to throughout the year. In fact, we love right triangles so much, we have a whole unit dedicated to right triangles. That's unit 7, all right? And in fact, my favorite triangle is a right isosceles. Those are some good-looking triangles. This is just your basic right triangle right here. A right isosceles, we'll talk about those later in the year. Very pleasing to the eye. All right, so we're going to do similar problems to yesterday, but we're going to take a massive shortcut. All right, we're going to use Pythagorean theorem. We're going to use the shortcut to find the approximate length of RS. So let's go ahead. We didn't practice this yesterday, but I'm going to force you guys to practice today. What's a good color? Dandelion yellow. R, so it's 3, 5, so right 3, up 5. All right, you're not always going to have the points plotted. You have to make sure you know how to graph coordinates. Then we have S is -4, 2. So left 4, up 2. Even me, a teacher, sometimes I goof up the coordinates. Sometimes we just brain fart and mess up. So let's make sure we pay attention to detail, do it correctly, all right? So we have the distance formula. We could do that, we did that yesterday. Very lengthy, very detailed, but watch this. This is the Pythagorean theorem shortcut. I'm gonna take this segment and boom, I'm gonna make it into a right triangle. Ooh, ah, wow. All right. Then I'm just going to count this length right here. All right, count the spaces. So when I start at S, that's 0, so it's 1, 2, 3, 4, 5, 6, 7. All right, so that has a length of 7. And then this leg right here has a length of 3. All right, and A and B are interchangeable. I'm going to say A is 7, 3 is B, and C is the hypotenuse. All right, so we have Pythagorean theorem. We didn't write it up here, but we know that A squared plus B squared equals C squared. All right, Pythagoras was a very powerful mathematician. All right, so this is all I have to do. It's still actually the distance formula of what we're doing. It's just a very simplified version. All right, 7 squared plus 3 squared equals C squared. And once we get this far, it's just a matter of computation where I'm going to get 49 plus 9 equals C squared. I'm going to write C squared now equals 58. I swapped the sides, or swapped the order, and then did the addition. Take the square root of both sides, and C is going to be a number incredibly close, not exactly, approximately, square root of 58, 7.6, about 7.6. All right, so just recall from yesterday, we were doing loads of work, a lot of computations, lengthy formula, plugging in things correctly. Got to be able to do that, but in the future, if you have a problem like this, I would do the Pythagorean theorem shortcut. Easier, quicker, so on and so forth. So we need to know the distance formula, but let's know how to use the Pythagorean theorem shortcut as well. That way, we can make life easier on us. So we're going to do another problem. All right. So our S are 0, 4, so 0 on the x-axis, 4 up. So that's R. Then S is negative 3 on the x-axis, 0 up, S. All right, cool, neat. All right, then we're gonna make this into a right triangle. All right, so I'm gonna say A is 3, I counted the spaces, B is 4, I counted the spaces, C is the hypotenuse. So this time I'm gonna write C squared equals A squared plus B squared. I actually like writing it like this more. I like what I'm solving for on the left-hand side. Technically, it doesn't matter. You can write it however way you want, but just make sure you plug in things correctly, do the correct computations, avoid brain farts, all that stuff. So we do it, plug it in, do some computations. We get C squared equals 25. Take the square root of both sides. C equals 5. That right there. All right. So distance formula useful for real life problems. You remember when we found the distance between Darby and Davidson yesterday? Those were crazy numbers, and we had that follow-up problem with some decimals. Pythagorean theorem shortcut, this really only works with whole numbers when you have a picture or a graph to go along with it, and when the numbers are close together. So very specific times where Pythagorean theorem shortcut works. Distance formula is kind of like the foolproof method. All right, Canvas problems, do this on your own. In Canvas, you're never going to include x equals in your answer. Do not. Just write the number. So on your calculator, I'm going to make up a number. If you got 8.15, it says round to the nearest tenth. In Canvas, so this is what you got on your calculator. In Canvas, all you would do is type 8.2 because that's the nearest tenth. So read the directions. Make sure you input the numbers correctly. Never write x equals. All right? That's from my class. I know previous teachers might have had you do this, but I like to keep it simple. Just the number. All right? Do these two problems, and then we'll come back and talk about this one.